Hello, everyone listening in. Today, we're going to be talking about the topic fractions, which belongs to the subject of mathematics. And let's just get into it. So, a fraction is basically something that conveys a part or something less than a whole of a group or a region. Okay, and an example of that, as you can see on the board, is 5 by 7. And typically the top part of a fraction before the horizontal line is called the numerator, and the part below it is called the denominator. And the part below signifies the denominator, that is, signifies the number of parts into which you're dividing whatever object you're making a fraction out of, and the numerator is the number of said parts that you select. So there's two types of fractions on the basis of relative size of numerator and denominator: proper fractions and improper fractions. A fraction in which the denominator is numerically larger than the numerator is called a proper fraction. And intuitively, you can tell that a proper fraction would have value less than 1. The denominator of a proper fraction, as I've said before, denotes the number of equal parts into which a whole is divided, and the numerator shows the number of such parts that have been considered. Improper fractions are an exact opposite to proper fractions. That means that the numerator in an improper fraction is going to be numerically larger than the denominator in an improper fraction. And clearly, the value of an improper fraction would be greater than 1. So that's the easiest way to recognize an improper fraction. And the way you can think of an improper fraction is a combination of certain wholes or entire objects accompanied by a fraction or a proper fraction. So to give you an example, 9 by 7 could be split into the number 1 plus 2 by 7, and we will see how to convert it back to its improper fraction form in subsequent slides. A mixed fraction is basically similar in representation to the example of the previous slide, that is the 9 by 7 splitting into 1 plus 2 by 7. And essentially it conveys both the number of whole parts and the fraction associated with an entire number, and its representation is the number of whole parts that you've taken in. So for example, in 5 by 2 that would be 2, and just to the right of that you write the fraction that's left over, and the calculation for the same seen below. So you got 5 by 2 is split into the factor which is divisible by 2 and the remainder that's left, which is 1. So 4 by 2 translates to 2 whole parts, and then you go left of proper fraction of 1 by 2, and the two of them combined together form the mixed fraction 2 1 by 2. So an exercise along the same is on your screens now, and I'm just going to walk you through the first 3 or 4 of each of the following. So the first question is of expressing improper fractions as mixed fractions, and we'll start with the fraction 20 by 7. Now 20 by 7 can be written as 14 plus 6 the whole divided by 7. 14, as we know, is a multiple of 7, and 14 divided by 7 is 2, so it equates to 2 whole parts, and your leftover remainder part is 6 by 7, so the fraction will then become 2 6 by 7 in its mixed representation. Similarly, 13 by 5 will be split into 10 plus 3 the whole divided by 5. 10 is a multiple of 5, and once again the quotient of that division will be 2, and the leftover part is 3 by 5, so the mixed representation will be 2 3 by 5. And 47 by 9 is a complete whole number. That's a mistake on my part. 47 by 9 will be split into 45 plus 2 by 9, and 45 by 9 45 and divided by 9 yields the quotient 5, and you have a remainder of 2 by 9 associated with it, so the mixed representation will be 5 2 by 9. Now moving on to the second part of the exercise. For expressing an improper fraction as a mixed fraction, you multiply the whole number part with the denominator and add it to the remainder. and that becomes the numerator for the improper fraction, and the denominator stays the same. So for 5 3 by 7, we multiply 5 with the denominator, that is 7, which gives us the product 35. And 35 when added to 3 yields 38 by 7. So that's the improper fraction representation. 9 1 by 5 is 9 into 9. 1 by 5 can be written as 9 into 5 plus 1, the whole divided by 5. 9 into 5 is 45. 45 plus 1 is 46. So the improper representation will be 46 by 5. Now, a slightly trickier multiplication, but along the same lines, is 25 8 by 13. 25 into 13 will become 250 plus 75, that is 325. 325 plus 8 is 333. And the denominator remains the same. So the final improper fraction will equate to 333 divided by 13. The other questions that I have left out, which is number 5 and 6 in mixed fractions and 3 and 5 in improper fractions, can be solved in the same way. So equivalent fractions. Any fraction can have infinite representations that hold the same value. And the way that can be achieved is if you take a fraction, say 1 by 2 in this example, and you multiply the numerator and the denominator with the same term, make sure that it isn't 0, the fraction remains the same, like the value itself remains the same. And the way you can think of that is, imagine a cake. I'm just going to explain this through the 1 by 2 example. And imagine you make a slice right down the middle, and it's a circular cake. Now that splits your fraction, like your cake, into two halves. Okay, each half is represents 50%, or 1 by 2 passes the whole cake. Now I want you to think of another cut that you make perpendicular to the first cut. Perpendicular means it will form a 90-degree angle to the first cut. Now you should have 4 identical pieces of cake there. If you pick 2 out of those pieces out, it is the same amount of cake that was present in one half before the first cut, and hence it represents the same amount of the whole that was present before the first cut, while being a completely different visual representation. And that's how I'd convey equivalent fractions to you. So this essentially multiplying both numerator and denominator by the same number results in a fraction of equivalent value. Okay, and so the last example here is to find an equivalent fraction to 2 by 5 with the denominator as 15. So to get the denominator to 15, 5 has to be multiplied with 3. And to create the corresponding equivalent fraction, you've got to multiply 2 with the same coefficient, which is 3, and that results in the fraction being 6 by 15. So a simplest form of a fraction, though, as I've explained in the example for the cake, the simplest form of a fraction would, in that scenario, be the first cut, because you cannot club together any more pieces to form the same fraction. And let me just put that. So if you had 2 quarters after you made the second cut and you combined 2 of them, it became that 1/2, which was a simpler representation. So the mathematical way of saying this is when the numerator and the denominator have no common factor between them, then the fraction is supposed to be in its simplest form. And the way to test that is to just look at the highest common factor between the numerator and the denominator and divide both of them by the highest common factor. And the example below demonstrates the same thing. So we start with the fraction 8 by 12. Now the highest common factor of 8 by 12 is 4, because 8 and 12 is 4, because 8 is 4 times 2 and 12 is 4 times 3. So we divide both of these terms by their HCF, that is 4, and it results in the simplest form, which is 2 divided by 3. So exercise 2 discusses an equivalent fraction and how to convert to different equivalent fractions. And so for the first question, what I would do is basically just multiply both numerator and denominator by any possible number that you can think of apart from 0. And I'm just going to demonstrate it on 4 by 5. So 4 by 5, multiplying both numerator and denominator by 2 gives you 8 by 10. Multiplying both by 3 gives you 12 by 15. Both by 4 is 16 by 20. Both by 5 is 20 by 25. And then when you multiply both by 6, you get 24 by 30. And let's do the third example, which is 20 by 52. 20 by 52 when multiplied by 2 on both sides will be 40 by 104. Thereby into 3 would be 60 by 156. Into 5 would be 100 divided by 260. Into 10 would be 200 divided by 520. And into 20 would be 400 divided by 1040. Now, and the other two examples can be done in the same way. Just pick out 5 positive numbers, whole numbers, and just multiply both numerator and denominator by them. Now, for writing the equivalent fraction of 3 by 7 with numerator 9, to get the numerator to 9, 3 has to be multiplied by the coefficient 3, which means the denominator would have to be multiplied by 3 as well. And that will result in the final fraction being 9 divided by 21. Now, for numerator 15, 3 would have to be multiplied by 5, and 7 multiplied by 5, that is the denominator, would be 35. So the fraction would be 15 divided by 35, 15 by 35. And for denominator 49, 7 would have to be multiplied by 7 to get to the denominator 49, which would mean that the overall fraction then becomes 21 by 49. The simplest form of the following fractions, 15 and 25, have their HCF as 5. On dividing, you get 3 by 5. 24 and 16 have their HCF as 8. So the simplest form is 3 divided by 2. 20 by 35, 20 and 35 have an HCF of 5. So the simplest form is 4 by 7. 17 by 51, the HCF is 17 itself. And the simplest form will then become 1 by 3. 12 by 72, the HCF is 12, and you will have 1 by 6 as the final answer. Now, like fractions. Like fractions are numbers that can be directly compared, a fraction that can be directly compared, and this is only possible when they have the same denominator. If denominators are different, then they're called unlike fractions. So that's the counterpart. Same denominators, like fractions; different denominators, unlike fractions. So to compare like fractions, since the denominator is the same, you only look at the numerator. The higher numerator will always be more because it has a higher number of equivalent parts. So to reiterate, comparing like fractions is reasonably simple. You just look at the numeric value of both the numerators, and whichever numerator is larger has the larger fraction on it. So to compare unlike fractions is a little more tricky because fractions with different denominators means that their fractional parts are of different sizes and we can't compare them directly. So the simplest way or the only right way to do it is to get them to an equivalent fraction where they are both where both of them have the same size for their smallest fractional parts. And the way that we achieve this is by taking the LCM, that is the lowest common multiple of the denominators, and creating equivalent fractions of both the fractions that we're comparing, with the denominators being equal to the LCMs. So the way we do that is by multiplying both the numerator and the denominator by the coefficients that are required to get them to the equivalent fractions with denominator equal to the LCM. Another note that I probably missed out on was a shortcut for comparing unlike fractions occurs when the numerators have the same value. When the numerators have the same value, you just have to check the denominators, and the smaller denominator will equate to the bigger fraction because you have more parts of bigger fractions when you have a smaller denominator because you're splitting a whole into lesser parts. So yeah, that's a thought you need to bear in mind. When you have the same numerator and different denominators, the smaller denominator equates to the bigger fraction. So to compare 5 by 6 and 8 by 15, we would take the LCM of 6 and 15. The LCM of 6 and 15 is 30, and you can check that on your own time. And to get 5 by 6 to the denominator of 30, we multiply both 5 and 6 with the coefficient 5, which gives us the final fraction of 25 by 30. And for 8 by 15 to get to a point where its denominator is 30, you multiply both numerator and denominator by 2, and it equates to a fraction of 16 by 30. Now we get to the old situation where the denominator is the same. We simply compare the numerators. 25 is clearly a bigger number than 16. So 25 by 30, that is 5 by 6, is the bigger fraction between the two of them. And now we move to a slightly more complicated topic of addition and subtraction of fractions. Now, for like fractions, it's a relatively routine job because the numerators and the denominators for both fractions are the same. The numerators can simply be added or subtracted directly without any other conversion being need to made. Because, like I keep going back to the point, the same denominator means that you've got equivalent parts of a whole that you are adding or dividing. So you can easily do this without any conversion. But to add or subtract, unlike fractions, we have to make the conversions to equivalent fractions with the denominator LCM, as we checked for the previous question, and then add or subtract the resultant numerators. So an exercise for the same, the first question is extremely simple. You just add the numerators, which gives you 15 by 15, and that's the whole number 1. We'll do the third question. 4 by 5 plus 2 by 3, the LCM is 15. When you convert the two fractions, you get to 12 by 15 plus 10 by 15, and that equates to 22 by 15. Now, the fourth question is a little more tricky. You have 2 by 3 plus 3 by 4 plus 1 by 2. And the way we do this is by splitting up and adding two fractions at a time. So let's start with 2 by 3 plus 3 by 4. Now the LCM for 3 and 4 is 12. So we convert and we get 8 by 12 plus 9 by 12, which is 17 by 12. Now 17 by 12 has to be added to 1 by 2. The LCM for 2 and 12, that is the denominator, is 12. And when you add 17 by 12 to 6 by 12, which is the converted fraction, you get 23 by 12 as your final answer. Now for the final two questions, we'll cover both of them subtraction wise. 7 by 6 minus 1 by 3, the LCM is clearly 6, so it converts into 7 by 6 minus 2 by 6, which is 5 divided by 6. The sixth question is 4 by 3 minus 1 by 2, and the LCM is once again 6, so on conversion you get 8 by 6 minus 3 by 6, which is 5 by 6. And now we go to the comparison exercise. 3 by 15 and 8 by 15 is the common denominator case. The higher numerator is 8, so the higher fraction is 8 by 15. 13 by 7 and 4 by 21, you have to convert the denominators to an equivalent point. And for that, we multiply 13 by 7 on both the numerator and the denominator by 3. And that gives us 39 by 21, which is clearly greater than 4 by 21. For 11 by 17 and 40 by 51, we multiply 11 by 17 with 3 on both the numerator and the denominator, and that results in the fraction 33 by 51, which is less than 40 by 51. The other examples on this exercise can be solved with the same steps. And that's it. That's the last exercise. So I hope you guys have gotten a better idea of fractions, and it was great fun just talking over it and explaining the concepts. Thank you for listening.